All right, welcome back. So this will be, I believe, the last one for the AWS Machine Learning Associate Exam. Before we get started and finished, hit the like button, subscribe, and share with AWS. Anyone you know taking the AWS Machine Learning Associate Exam. All right, 181. A model needs to process images with varying resolutions from 100 by 100 to 4000 by 4000 pixels. The model requires fixed input size of 224 by 224. What pre-processing approach should be used? Crop all images to 224 from center. Resize all images to 224, maintaining aspect ratio with padding. Use only images that are 224 and train separate models for each resolution. B. So resizing maintains all image content, so there's no cropping loss. So you can maintain the aspect ratio to prevent distortion. The padding fills the remaining space to reach 224 by 224. This preserves the image proportions and content. And there's standard pre-processing for variable resolution inputs. And this works for all input sizes. How does this work? You calculate the scaling factors that fit within this. You resize to maintain the aspect ratio. You add padding with bars to reach that. You center or distribute the padding evenly. Why are the other options wrong? So if you crop this, you'll lose edge information and may miss important features. If it's only 224 by 224, this will discard most data, and it's pretty impractical. And separate models is inefficient and high maintenance. Question 182. A company wants to perform feature engineering on a large data set stored in S3, 10 terabytes. The transformations include complex joins, aggregations, and custom Python functions. Which service is most suitable? SageMaker Data Wrangler, Glue with PySpark, Athena, or Lambda? Glue with PySpark is designed for large-scale ETL. So that's 10 terabytes. Right? PySpark would provide the distributed processing for big data. This will support complex joins and aggregations natively. You can run custom Python UDF, so user-defined functions. It's serverless, so you can auto-scale for large data sets. And it's cost-effective for big data transformations. So Glue has a distributed processing, complex transformations, custom Python functions, and job scheduling and orchestration. Why are the other options incorrect? So Data Wrangler is for interactive explorations, not that large scale production processing. Athena is just SQL queries with limited Python support. And Lambda has a 15-minute timeout, which isn't suitable for that much data. Question 183. An engineer needs to track multiple experiments with different algorithms, datasets, and hyperparameters. The engineer wants to easily compare results and identify the best performing configuration. Which service is built for this? CloudWatch, SageMaker Experiments, CloudTrail, or S3 with custom logging? B. Experiments is purpose-built for this. It organizes trials, so those individual runs within experiments. It automatically captures metrics, parameters, and artifacts. There's a built-in visualization for comparing results. There's side-by-side comparison of different configurations. There's search and filter capabilities, and this integrates seamlessly with SageMaker training. So what are some features? There's automatic metric tracking, parameter capture, visual comparison charts, leaderboard views, and filter and search. Why are the other options wrong? So CloudWatch is just general monitoring. CloudTrail is API audit logging. And S3 custom logging is manual and can be done, but it's not really there for comparison. 184. A company deployed a model that initially performed well, but accuracy has gradually decreased over 6 months. The model hasn't been retrained. What's the most likely cause? The architecture is outdated, concept drift, hardware degradation, or insufficient training data initially. B. So concept drift occurs when the relationship between features and targets change over time. So the model learned old patterns that no longer apply. This is common in dynamic environments. Think customer behavior or market conditions. So the gradual decline over 6 months indicates evolving patterns. The solution would be to retrain with recent data. So what's the drift examples? Let's say a customer preference would evolve, economic conditions change, seasonal patterns shift, new products or competitors emerge. Why are the other options wrong? An outdated architecture would be evident from the start. A hardware degradation would affect latency, but not prediction. Insufficient training would show poor work from the start. Question 185. A SageMaker feature store has been created with both online and offline stores. What's the correct sequence of steps to use the feature store for machine learning training? You see the available steps: create the feature group, ingest records into the feature store, access the offline store to build training data, query the online store for real-time inference. The correct sequence would be create a feature group, ingest records, and access the offline store, and then query the. Okay, it looks like it was set up from the start. Let's see this. Oh, it didn't finish this out. So let's see. This is the correct one. Okay. So correct steps would be create the features group. This will define the schema, feature names and types. This will establish a storage structure is required before data ingestion. Then ingest the records. So this will load the features, the data into feature store. It'll write to both online and offline stores. It'll populate the feature repository. Then 3, access the offline store for training, which will query offline stores. So S3 and Glue catalog. It'll build training data sets with point in time joins and have historical data for modeling. And then step 4, the online store will be used for real-time inference, not training. Question 186. A company wants to host a model on SageMaker, and an engineer is configuring a continuous integration and continuous delivery pipeline and code pipeline to deploy the model. The pipeline must run automatically when new training data for the model is uploaded to an S3. What's the proper steps? Yeesh. Let's go to the answer. This is not done well. Okay, so it's probably simply once it gets dropped in there. Okay, so event notification, right? Step one, event notification. So there's new data uploaded to S3. This triggers code pipeline with the event-driven architectures without lifecycle rules. Step 2, SageMaker will retrain. So the pipeline will execute a training job using that data in the S3. It'll create the updated model artifacts. 3, it'll deploy to the endpoint. So the model will deploy directly to the endpoint for inference. It'll be ready for production use, not the model registry. SageMaker retrains. Yeah, so it would be the S3 event notification, SageMaker retrains, invokes the pipe lifecycle. Oh, okay. So that's where that is not correct. SageMaker endpoint. And then once it's to the endpoint, it'll go to the model registry. Yeah, that makes sense. So it has those kind of mixed in together. Sorry about that. 187. A global e-commerce company wants to provide personalized product recommendations. The system needs to handle millions of users and products with real-time updates as user behavior changes. Which service is designed specifically for this? SageMaker with custom recommendation algo, personalize, comprehend, or Glue with collaborative filtering. Personalize is purpose-built for this. It scales to millions of users and items automatically, has real-time recommendation updates. It handles user item interactions automatically. We've already done this question. So let's say, why are the other options incorrect? So custom SageMaker, that's custom, right? It requires a lot of expertise. Comprehend, NLP. Glue is an ETL service. Okay, so a model requires GPU instances for training. The training runs for 12 hours. The company wants to minimize costs while ensuring the job completes successfully. Which approach provides best cost optimization? On-demand GPU, that's managed spot training with checkpointing, reserved instances for GPU, or serverless training? B, so managed spot training provides significant costs, so up to 90%. Checkpointing ensures progress is saved, and if interrupted, it can resume from the last checkpoint. For 12-hour jobs, the interruption risk is acceptable with checkpointing and significantly cheaper than on demand with a built-in retry mechanism. So how would you do that? You'd save the checkpoints every 30 to 60 minutes. If interrupted, resume from the checkpoint. You'd see the cost savings, and then you'd have extra time from interruptions that would hopefully be acceptable. Why are the other options wrong? So on demand is most expensive. Reserved instances is not applicable for SageMaker training, only EC2. And serverless is not available for training, only inference. 189. The company has customer data in multiple formats. So structured data in RDS, unstructured text in R-Story, and real-time clickstream data in Kinesis. The company wants to build a unified customer profile for machine learning, which AWS service helps create a unified customer view. SageMaker Feature Store, SageMaker Glue Data Brew, Amazon Redshift, or DynamoDB. So Feature Store is designed for a unified ML feature repository. This will ingest features from multiple sources like RDS, S3, Kinesis. It'll have an online store for real-time features, an offline store for training, a point-in-time join for consistent features, and purpose-built for machine learning feature management. So this has a centralized feature repo, consistent features across training and inference, feature sharing across teams, versioning, and lineage tracking. So why are the other ones incorrect? So Data Brew is a data preparation tool, not features repo. Redshift is a data warehouse. And DynamoDB is a database that lacks feature stores. 190. An engineer needs to ensure that inference requests to a SageMaker endpoint are authenticated and authorized. Only specific IAM roles should be able to invoke the endpoint. Which approach provides the most secure solution? Use an endpoint with public access keys and API keys. Configure IAM policies restricting the invoke endpoint permissions to specific roles. Use VPC endpoints without authentication. Implement custom authentication in Lambda. So, B, IAM policies will provide that fine-grained access control. You can restrict invoke endpoint permissions to specific roles or users. You can have AWS SIG v4 authentication so it ensures requests are authenticated. It'll integrate with AWS audit and compliance tools. There's no custom code required, and this will follow the AWS best practices. And you can see the example of the JSON with the IAM policy. Why are the other options wrong? So API keys are less secure than IAM, and it's harder to manage. VPC without auth is network isolation, which is not sufficient. In custom Lambda, this is overly complex. It's too much operational overhead. Question 191. An engineer needs to process thousands of existing CSV objects and new CSV objects that are uploaded. The CSV objects are stored in a central S3 and have the same number of columns. One of the columns is a transaction date. The engineer must query the data based on the transaction date. Which solution will meet these requirements with the least operational overhead? So Amazon Athena, create table, and create the table based off this, query the objects from the table. Create a new S3 for process data, set up S3 replication, use S3 object Lambda to query. Create a new S3 for process data, use Glue for Apache to create a job to query the CSV based on transaction date. Configure the job to store results in a new S3. Create the objects from the new S3. Create a new S3 for process data. Use data Firehose to transfer the data from central S3 to the new S3. Configure Firehose to run a Lambda function to query the data based on the date. Yeah, those are complex. So Amazon Athena create table select statement to create a table based on the transaction date from the data in the central S3, and then query the objects from the table. So Athena has minimal operational overhead. This has a serverless SQL query service. So there's no additional infrastructure to manage. It has direct S3 querying, right? So you can query in place without requiring data movement, like those other options that said to create the buckets, right? There's partitioning support, so you can partition by transaction date for query optimization. It's cost effective, right? And there's no ETL required. So it's schema on red, which approaches, that approach eliminates the pre-processing pipelines. And so you'll see an example of how that works on the bottom left, and then why not the other options? So S3 replication with object Lambda is overly complex. That Lambda that's too manual. And the same with Firehose. And Firehose also works with streaming data. So, and then Glue with the new bucket is a duplicate storage, requires orchestration as well, additional overhead. That's why the other ones weren't. 192. A company is building a web-based AI app using SageMaker. The app provides experimentation, training, a central model registry, model deployment, and model monitoring. The app must ensure secure and isolated use of training data during the lifecycle. The training data is stored in S3. The company experiments with consecutive training jobs. How can the company minimize infrastructure startup time for these jobs. Use manage spot training, SageMaker manage warm pools, SageMaker training compiler, SageMaker distributed parallel library. You can see which one is checked. So SageMaker managed warm pools. So these are pre-provisioned infrastructure that keeps the training instances running between consecutive training jobs. This eliminates cold start to bypass the EC2 instance provisioning and container image pulling. It's designed for iterative experimentation, for rapid model iteration, hyperparameter tuning, and it's cost-effective for frequent jobs. So you can pay for the warm pool retention only when actively experimenting. So why not the other options? So managed spot training optimizes costs, but increases startup time due to spot instance acquisition delays. Training compiler. This optimizes training speed by compiling models, but doesn't reduce the infrastructure startup. And distributed data parallel speeds up training through parallelization, but not infrastructure provisioning. 193. The company has a large unstructured data set containing many duplicate records across several key attributes. Which solution on AWS would detect duplicates in the dataset with the least amount of custom code development? Mechanical Turk, QuickSight ML, SageMaker Data Wrangler, or Glue Find Matches? You can see what's checked is Glue Find Matches. So this is purpose-built for deduplication. This is a machine learning powered transform specifically designed to identify duplicate and matching records. So it'll have fuzzy matching, so it'll handle variations in data like typos, abbreviations, or format differences. It has minimal coding, which has a visual interface in Glue Studio, so it doesn't have custom machine learning model development required. It's scalable, so it'll process large data sets using Glue's Spark infrastructure. It has active learning, where you can label a small sample, and it learns the patterns. Why not the other examples? So Mechanical Turk is a manual labeling process, and it's not good for large data sets. QuickSight is a business intelligence tool for anomaly detection and forecasting, not deduping. SageMaker Data Wrangling is great for data prep, but would require custom code for all the matching. 194. A company needs to run a batch data processing job on EC2s. The job will run every weekend and will take 90 minutes to finish. The processing can handle interruptions. The company will run the job every weekend for the next 6 months. Which EC2 instance purchasing option will meet these requirements most cost effectively? Spot instances, reserved instances, on-demand instances, dedicated instances. Spot instances. So this job can explicitly handle interruptions. There's a low probability of spot interruption during execution. There's significant cost savings compared to on-demand. There's a predictable schedule with weekend runs, and you can implement checkpointing and resume for fault tolerance. So why not the other options? B, reserved instances waste capacity during the weekdays, and at 6 months doesn't justify the commitment. On-demand has higher costs, and dedicated instances are also expensive. Question 195. An engineer has a comprehend custom model in account A in the US East 1 region. The engineer needs to copy the model to account B in the same region. Which solution will meet this requirement with the least development effort? Use S3 to make a copy, transfer the copy to account B. Create a resource-based IAM policy, use comprehend import model API to copy the model to account B. Use data sync to replicate the model from A to B. Create a site-to-site VPN between A and B to transfer. So it's B. Create a resource-based IAM policy. Use comprehend import model API to copy the model. Why is this? It's the purpose-built API for cross-account model sharing. You can have a single API call with IAM policy configuration. It'll maintain the model version, training metrics, and configuration. It'll reference the existing model artifacts without duplication. And CloudTrail will log all the operations for compliance. So why not the other ones? So S3 copy. So comprehend models aren't stored as simple S3 objects. It's a complex internal structure. Data sync is for file system and object storage replication, not ML model sharing. And site-to-site VPN would be a network connectivity solution, but it would be overly complex and it wouldn't support the model importing. All right. So thank you for joining. That will be all of this section and the whole AWS ML Associate question and answer section. Hope you enjoyed this. Before you go, hit the like button, subscribe, and share this with anyone you know taking the exam. But until then, thank you for joining and have a good day.